Hi, my name is Hadir Skanda. I'm a BCBA, and this is a brief summary of Chapter 4, Applied Behavior Analysis, the second edition. Chapter 4 speaks about measuring behavior. And measurement is basically assigning numbers to represent the observed extent of a dimensional quantity to an appropriate unit, which is basically the idea of using numbers to explain a behavior, explain a measurement, or something you are trying to study. So, for example, we can say a child ran for 30 minutes. So 30 is a number you are assigning to the behavior of running to explain what happened. Also, frequency, you could say a child raised his hand 4 times within 30 minutes to answer a question. So these are all numbers we use to explain a behavior and basically, again, to represent the observed extent of a dimensional quantity to an appropriate unit. Researchers and practitioners need measurement. So if you're doing a study, you really need to measure what you're studying, and you need to present it in your study results. And practitioners, of course, need measurements to evaluate their program effectiveness, and for others to be able to replicate either a study or a program. So measurement is always needed in applied behavior analysis. So there are measurable dimensions of behavior. So for example, such as a coffee table, we need to know the measurement or the dimension of the coffee table. We look at the height, width, depth, and weight. When it comes to behavior, we look at repeatability, temporal extent, and temporal locus. Let's look at each of these. Repeatability. So the dimension of repeatability is measured by count, rate, frequency, or acceleration. Count is basically counting something. So you could say the behavior happened 5 times or 10 times. It's basically just counting how many times it happens. Rate and frequency is the same as count, except that you're also looking at the time. So you're saying it happened 5 times within 30 minutes or 10 times within an hour. Acceleration is the rate across time or throughout time. So either the behavior is increasing or decreasing. So acceleration looks at the behavior within a time and across time. So for example, you look at a behavior for half hour, and then you look at it again in the next half hour, and again in the third half hour, and you measure if the behavior is increasing throughout the time or decreasing. Acceleration is explained in full in chapter 6 and the acceleration charts as well. Repeatability is not used with discrete trials, nor measure continuous behaviors that occur for extended periods of time. So repeatability or count or rate or acceleration are not used to measure behaviors that occur for extended time, such as running, flapping of the hands, clapping. We use duration when it comes to behaviors that don't have a discrete beginning and end. Temporal extent is a dimension that's measured by duration. So you can measure duration per session, duration per occurrence. So duration per session is how long does the behavior happen within a certain session. Per occurrence is how many times how long does it last when it happens. And you can combine count and duration for some behaviors. So again, you could say it happened 5 times within an hour. And also you could say it happened 5 times, and every time it happened, it lasted for 10 minutes. That's the way you combine count and duration. So for example, tantrums. You can say the child tantrum an average of 5 times during a school day, and each time he tantrums, the tantrum lasts for an average of 10 minutes. That's a combination of count and duration. Temporal locus is measured by response latency and inter-response time. Response latency is basically the time between the stimulus presented and the behavior. So for example, if a teacher asks a question and the student answered, response latency will be the time between her question and his answer. So we use response latency when we want to know more about how long it takes a child to answer a teacher, how long it takes him to respond or follow direction, and that's basically between the stimulus and the behavior. Interresponse time is the time between successive behaviors. So if same behavior happening over and over, we're interested in the time between the first behavior, the time between the ending of the first behavior and the beginning of the second behavior. So for example, if a child is asked to answer a worksheet solving math problems, we may want to know how long it takes him to go from one question to another. Of course, we can use these with students who are impulsive, so they take very quickly to answer a question and then go to the next one. It also can work with children who take a very long time to go from one question to another. Maybe children who are inattentive or have focusing issues, so they may finish one problem and not go to the next one right away. So we may be interested in measuring that time between one question and the second question, and that's what we call interresponse time. Derivative measures. So derivative measures are basically the measures that we find or figure out by looking at the dimensions we spoke about. So percentage, it's a ratio formed by combining the same dimensional quantities such as count or time. So for percentage, if you're looking at count and you say it happens, I gave him 10 questions and he answered 5, so that's 50% of the questions. If you're looking at time, you could say he kept jumping 30 minutes, the duration of 30 minutes within the hour, so that's 50% of the time. That's how you calculate percentage. Trials to criterion is basically the number of responses needed to achieve a predetermined level of performance. So if you are teaching the child how to tie his shoelace, you're interested to know how many times it will take him to get to the criteria you had predetermined. So it could take him 10 times of trials, 11 times, 12 times. So these are the number of responses needed for him to achieve the criteria set for him. Definitional measures topography, so form, the shape of the behavior. So if you're painting, the way you're drawing the lines, these are the form or the shape of the behavior. Sitting with good posture, so that's another way of topography, measuring the shape or the form of the behavior. Also, we spoke about sports before, so you'll be interested in the topography of specific behaviors while you're playing a sport. Maybe the way you're standing, the way you're holding the golf club, the way you're throwing the ball. So these are another ways to measure behaviors. Magnitude, it refers to the force or intensity the response is emitted. So for example, how much pressure you have to put on a stamp to be able to use a stamp. Pencil on paper, how much pressure you need to put how much pressure you need to put for the pencil to be able to write on the paper. Screwdriver force, to be able to put a screw on the wall or use a hammer. These are magnitude, meaning it's not really the form or the shape of the behavior, but rather the force of the behavior. And it's important because, as these examples show, without specific way or specific force, you may not be able to stamp or write. And we see these some children have fine motor delays where they cannot hold the pencil and put the pressure needed to be able to write legibly. So that would be a measure we can use to help these students and figure out what's the pressure needed compared to the pressure they're using at that moment. So procedures for measuring behaviors, there are three procedures: event recording, timing, and time sampling. Event recording is the number of times a behavior happens. So you can use counters to figure out how many times. So that's just a count. You're counting how many times a behavior happens. You're not, you're recording each time a behavior happens, and you're not skipping, or there are no conditions on which you have to follow in order to record the behavior, such as, time sampling. We will see this in a minute. Event recording, you're eventing everything you see. Timing, so it's again duration of the behavior, duration of response latency or inter-response time. These are all timing, and you can use a stopwatch to be able to measure it. So now let's talk about time sampling, and these are discontinuous measurements. So observing and recording behavior during intervals or at specific moments in time. So there are three kinds of time sampling: whole interval recording, partial interval recording, momentary time sampling. We're going to talk about each one of them, but also there's planned activity check, which is used with a group of a large group. So you use head counts to measure group behavior at the end of each interval. So if you're looking at a classroom with 30 students, you are going to look at the whole group at the end of the interval and see how many students are engaging in a certain activity and how many are not engaging. That's an example, of course. All time sampling provide an estimate of the actual occurrence of the behavior, so it's not exactly the occurrence of the behavior because it's not event recording where you're eventing every single behavior or response. You're only getting at sampling, as the name implies. So let's look at these time sampling. So the whole interval recording is basically you are you're setting intervals, say of 10 seconds, and you're going to observe for 30 minutes. So every 10 seconds you are going to record if the behavior happens or not. Now this is how it works when you do whole interval. If the behavior continues to happen for the whole 10 seconds, then you record that it happens. But if it continues to happen for less than the 10 seconds, then you don't record it. So if the behavior continues to happen for 9 seconds, still you do not put a check mark that it happened, because the criteria here or the condition is 10 seconds. The interval is 10 seconds, so it has to occur from the beginning to the end. Of course, this is used more with behaviors that are they don't have discrete beginning and end, such as running, jumping, flapping, and so forth. Partial interval recording are again, it's the same way. You have intervals of whatever, 10 seconds, 20 seconds, depends on the measurements, and you are recording the behavior if it happens or not. If the behavior happens more than once, you're still going to check that it happens regardless of how many times it happens. So you're only interested if it happens or not, regardless of the frequency. Again, this is a time sampling procedure used with behaviors that have a beginning and an end. So raising hands to answer a question, answering or responding to your peer, the behaviors that really need counting or frequency, not duration. Momentary time sampling is basically the way you measure it is, again, you still do the same thing. You have intervals, and every 10 seconds you are recording the behavior. So what happened is that after the 10 seconds, you look at the behavior in this very moment and check if it's happening or not. So that's why it's called momentary, because you are interested in the last moment of the 10 seconds and you're looking to see if the behavior is happening or not. If it's not happening, regardless of the 10 seconds that happened in the 10 seconds, you are not going to put that it's happening. But if you look up and it's happening, then you will check that it's happening regardless of what happened in the previous 10 seconds. This is a very good procedure for teachers or someone who is not able to observe the whole time the student. So every 10 seconds or 20 seconds or whatever, the measurement is, they look up and record if the behavior is happening or not. Of course, it cannot be used with all kind of behaviors. As you can imagine, some of these recordings can overestimate or underestimate the behavior. So we have to be very careful when we decide which measurement procedure we should use. Then there are measuring behavior by permanent product. So measuring behavior after it has occurred by measuring its effects on the environment. So, for example, biting at night. So if you have a person who bites himself only during the night time, you're unable, of course, to observe him during that time or go in the bedroom at that time. You have a permanent product, which is the marks of the biting on the skin. So that's something you can look at and measure if it happened or not based on the permanent product. So it's really measuring not the behavior itself, it's the effect of the behavior on the environment. Math problem completed or homework. You can tell if it's completed or not. So if you're giving a test and you're collecting the papers, you would look and see the permanent product, which is the answers written by the student. So you're looking at the effect of the behavior to calculate the measurements of how many math problems were completed. Of course, it's great for practitioners to do other tasks and enables the measurement of behavior occurring at inconvenient time or inaccessible places. So you still can measure some behaviors if you're unable to observe them directly, if there's an effect on the environment that can be seen afterwards. And that's what we call permanent product. Computer-assisted measurement of behavior. So there's a lot of softwares that can be used to calculate measurements and take measurements. So it's allowing for the measurement of multiple behaviors across multiple dimensions. So if you're really interested in comparing data and looking at different dimensions and comparing them, and it's a very tedious process for you to do it by yourself, computer-assisted measurement of behavior such as a software can help do that for you. So this is chapter 4. It's a brief summary, and it's a brief summary of my own understanding. Thank you so much.